Okay, so yeah. Given a memory size of 65536, 2 to the 16, can we do that? 2 to the 16 plus 2 raised to that, okay? Sorry, equals this raised to the 65536. Kunin doon natin equals log 2. Where's log 2? Log 10 kasi wala palang log ayan. Baka pwede ito I am log 2. Returns that base 2 logarithm of a complex number. Maybe. Hindi, log base 10 eh. I am log 2.
Murag second parameter ata tungon sa sir.
Sige,
Yung
parameter.
base.
Okay. Sige, ilagyan natin yan. Log equals. Asa mo equals? Equals. Log comma 2. Yes, no? So, kuha ni mong log, that will become the exponent. If you are going to raise the exponent, that becomes the number. Okay. So, given a memory size of 65536 and a cache memory of 8192 bytes and a block size of 1024. Gagamitin natin yung ating Do you follow? Excel. Example natin sa Excel, no? Cache mapping, okay? Can we map that out so that we can understand it properly, you know? Okay. Okay. Meron pala tayong isa dito. Let's save it. Don't save that, okay? So, given a memory size of 65536 and we have a cache of how much is each line? 1024 bytes each line and 8192 bytes. So therefore we will have how many lines in the cache?
8, sir.
8 lines in the cache. Okay, so kukupihin lang naman natin itong nandito, direct map cache, no? 8 yung ating example pala, no? 1, 2, 3, 4, 5, 6, 7. Maswerte tayo, 8 yung ating example. Letter I. Halos pareha lang sa ating example. So ito yung ating cache, no? What's the last number here? If we have 1024, so this is 1023, right? Okay, you follow? Ito yung addresses ng ating each cache. Okay, this is 0. This is the offset addresses. 0, 1, 2, 3, and then 4, and then the last is 1023. You follow? Ito yung offset address natin. 1023. What is 1024? Log 2 of 1024. Was log offset, because that gives us the offset, right? So 10 bits ito. Do you follow? 10 bits yung ating offset. Do you follow? Any questions about that? Because each line has 1 kilo. So from 0 to 1024. Ito, this is 1024 to 2047. This is 2048 to 319 something, no? And then hanggang, di ba? Do you follow? So this is 0 to 1. Every one of this is 0 to 103, by the way, no? So if you have 1024, we have 10 bits of offset. Do you follow? Do Do you have any questions? Madali lang, no? We know exactly that this is 10 bits, okay? Given a memory size of 65536. So ating memory size is 65536. We have 16 bits. Okay? How much is the offset? 10 bits. Tama ba 'yan?
Yes, sir.
10 bits, di ba? Log 2 of 1024. And then how much is the 65536? The address is 16. Okay? 16 bits kasi 655 2 to the 16, okay? 65536. Okay. And cache block. So ang ating cache address is how many? Address. How much is the cache address? Anyone? It's 3 bits. Diba? 3 bits kasi 0 to 8. Do you follow? Do you follow? Any questions? 0 to 8
Paano
man.
malaman, sir, ilang bits kailangan para sa cache address, sir?
How many blocks are there in the cache? Sinabi
8,
dito,
sir.
8. So, log 2 of 8.
Sige,
3.
sir.
Di ba? Log 2. I-log 2 natin kasi ito ang unang block is 000. Next block is 001. Kahit hindi mo i-log 2, alam mo na yan. Di ba? Di ba? Because we know that there are 8. So, first address is 000, 001, 0. The last address is 111. So, there are now 8 of them. So, you now know that there are 3 bits. Even if you don't log 2 of 8. Do you follow? Okay. Determine the block number of the block address in the following addresses. Saang block siya papunta? Sa cache. Do you follow? One is, kung hindi kaya ito mag-ano, no? Hindi kaya ng debt to bin. 24,128. You have to convert this to binary. Kung hindi kaya, equals debt to bin. Kasi paminsan hindi kaya eh. Na hindi kaya talaga. Okay. Do you know how to convert this? Isulat na lang muna natin, no? One is 24,128. 24,128. Can you see my ano? I'm sorry, no? Determine the cache block address. The block address in memory, no? And the cache block address, no? Madali lang man ito no? Kukunin natin yung tag from the memory block. We know the cache address, okay? Do you follow? The memory block. Okay, so 24,128. So kung 24,128 we need, di ba? Alam niyo, mag-compute 1, 2, 4, 8, 16, 32, 64. Dahil lang naman to, ano lang sa simula, pero pag magkapatong tayo ng 1,000, 128. Okay? Ganito na lang. 1, 2, 3, di ba? So that we can expand this. Okay. Bakit ayaw? Ayaw, no?
Sa lower right side yung mong unsaon sir i-drag.
Sa lower edge.
Kanang na yun sa.
Okay. Kining na igamay dire. Ano lang. Okay, and then we will raise this to the 2. Para hindi tayo mahirapan mag-compute. Okay. We are trying to convert. You have to convert to binary, no? so that we will know the cache block address and the cache tag address. Okay, this equals to raise to this. Can you see my worksheet? Lagyan ko na lang, no? And then I'll okay. I-upload ko to, no? I'm going to upload this. Di pa ba natin ito na compute? What kind of address is this? Wala namang problema pala. Ito lang problema. Okay. Okay. So, klaro na dito, no? If you have, out of 16, you have 10 is the offset and 3 is the, no, the tag is, how much is the tag? 3 ang tag. Di ba? Kasi 3 na lang naiwan eh. Do you follow? Okay. Kasali na dito na ang 24. Kasali na ang 24. Ilan ba sila? How many do we have? 24, 1, 2, 8, 25. O, kasali na. Do you follow? Okay. And then what will we do? We will have, okay, equals this times that. Okay. Gawin natin 0 ito. Para malaman natin kung ilan ang ano. This is a traditional way, no? To compute. Okay. So ito ngayon, ito equals this times that. Okay. Tapos isum natin. We're computing this kasi ayaw mag-compute ng ano. Ayaw mag-compute ng deck to bin. Okay? Do you follow? And then what we'll do is equals that minus this. And then gawin natin red ito. Okay? Do you follow? Para malaman natin. Now, we need dapat pala una tayo dito sa ano, no? Sa 16, we need a 16384. Yes. So, bakit nagkaganon? 24 na lang. Dapat napakaliit. False exam natin ito. Baligtad, no? Baligtad ba ako? Yes. Baligtad. Sorry, no? Wala tayo sa 15. Hanggang sa 1. Okay. Okay. And then this will be equals to raised to 15. Okay. Bigay na lang tayo ng isa. No? Kasi 16-bit addresses tayo, di ba? Okay. Sorry. Sorry na. 16-bit addresses daw tayo, no? Kumplituhin na lang natin, no? We're just computing binary here, no? Wala naman tayo ibang ginawa. Ayaw mag-compute nga ng depth to bin. Paano ipa-compute yung depth to bin ng malaki? Okay. Tapos ito, yeah. I equals this equals this times that. Okay? I-sum natin. We'll sum this. This is the sum of our new ano. Para malaman natin kung how much is left. Tapos we'll subtract equals that minus this. And then that's red. Okay? Do you follow? So 24128, we cannot have a 65536. We cannot have this. We can have one of this. Okay? I-mark natin 1. 1. Bakit 24127 lang?
Sir, baka dapat ilagay mong 1 sa taas. Sir.
1 kasi equals sum.
Above.
Sum dapat, bakit naging 1?
Baka ilagay mo ang 1, sir, sa row above na gilagyan.
Oh, sorry. Mali. Mali ang nilagyan ko, no? Kaya 1, no? So, Control C, Control V. Okay? Dito tayo maglagay ng 1. Okay? So, 774. 7,000. So, sobra na yung 8. So, ito 1 tayo. Okay? Do you follow? Bakit nag-36? Yeah, 36 na lang. Ang kulang. Okay, we can have a 10248. 16 na lang kulang. So, we can have this. 576, we can have this. Okay? 64 na lang ang kulang. So, we can have this. Okay? Do you follow? So, we'll just color the ano na. We'll just color. The offset is 10 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, i-color natin ito. Gawin natin yellow. Merge cell. What's this? This is the offset. Okay. And then we'll center this. Diba? Tama ba? Offset address ito, 10 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sobra. 1, 2, yeah, sobra. Sorry, no? Ano ito ngayon? Dapat sa 10, namali ako pag ihap, no? Pagbilang. Okay. So, hanggang dito lang. 1, hanggang dito lang, nasubrahan. Format cells. Merge cell. Okay. Do we save it? Ano exercise nga ito? Sample exercise in ano? Direct map cache. Ano lang, no? Kasi mahirap itong aking Excel. I don't know why it goes the wrong way. Direct map cache muna. Upload ko ito, no? Anyway, it's uploaded already, no? Pero wala yung solution. Okay, so this is the offset address. How many address is left? Gawin natin yellow ito. Okay? Kasi yellow eh. Oh no, sorry. This is black. And then gawin natin yellow dito. Bakit ibang klase pagka-yellow? Do you follow? Okay, so ilan na iwan? 1, 2, 3, 4, 5, 6. Okay, so ito, this is what? The cash. Diba? This is our cash. How do we know that this is the cash? Because of course there's 8. So gawin natin itong green. And of course this is the tab. And then we'll make it this. Anong color you like? Red. Kasi red yung ating hinahanap, di ba? Ang tinatanong is the, do you follow? Okay. So anong tinanong? Okay. What is the memory address? What is the memory address? Ito. Ang memory address is the combination of the tag and the cache. Memory block address. Diba? Right? So therefore, what's the memory block address here? Okay, sorry. 0, 0, 0, 0, 1, 1, 0, 0, 1, 1. Tama ba? Ay, isang 0 lang. So ito, pwede na ito i-bin to deck. Right? Kaya, no? Oh, 11. Okay? Do you follow? It is the 11th block in memory. Did you get my point? It is the 11th block in memory. Okay? What is a block size? Determine the block number in memory, no? And the cache block address of the following. What's the cache block address? What is address in the what is the address in the cache? The address in the cache is 011. 011. Okay? Ito pwede rin natin ma-deactivate. Okay? 3. So dito siya sa third. Okay? Dito siya sa 011. Ito. Did you follow? Any questions? Itong number 2, kupihin na lang natin, no? Number 2. Okay. So saan siya sa cache papunta? Sa cache block number 3. Which block in memory did it come from? Cache block 11. Okay. So number 2 ito. So what's the problem there? 25152. 25152. Okay. Zero out muna natin ito lahat. We have to zero out all of this. Okay. 0, no? 25152. For 25152, we'll need one of this. We'll need this, no? How much is left? 16. No, 876. So we will not need this. And 576. So we will need this. And 64. Finally, it's 64. So we'll need this. Do you follow? So this is now the offset address. So what's the memory block address of this? Is the tag and the cache. It's 011 100. Okay. So this is memory block number 12, and it's ano is 100. So it will reside in cache block 4, which is this block. I-follow ako, peke ko na lang yung color, no? Anong color ng 011? Red. Red. Itong isa is 4, sky blue. Yata, no? Hindi. Ito. Ito ba? Mauna na siya. Okay? Do you follow? Do you get my point? So it is memory block address 12. It will go to cache block address 4. Okay. 26176. Okay. 26176. We'll copy this. I'll upload this now. $26,176. So we'll zero this out. We'll zero this out. Okay, it's 0 now. Okay, so for 26176, we will need a 16. We're left with 9K, so we need an 8K. 16K. So 16K is this. No? 576, we need a 512, and 64 finally. Admit Jesus. Jesus, na-admit na. Okay. 64, we need a 64 here. And finally, it's 0. Okay. So what's the memory block address? It's 001 00 00 001 100. Bakit pareho pa rin? I'm sorry, no? 26176. Tama ba tayo? O, pareho pa rin sila. They share the same block address. Magkaiba lang sila ng offset. Do you follow? And the cache block address is still the same. So dito, this is a miss and replace. Kasi magkaiba sila ng tag. Bakit pagkapareha? Sandali lang. Magkapareha pa rin sila ng tag because they actually belong to the same cache. The same block. Do you follow? Kasi ito, wala lang itong 1K. Equals this minus this. 1024, exactly 1024. So this is the end of the block. Do you follow? So this and this are on the same block in memory and the same tag, no? Magkaiba lang sila ng offset. Any questions? No? So nasa edge ito. This is on the edge of the block. Let me upload this, no? So you can have this as a sample. Nandito na yung solution niya. Tingnan natin yung solution kung tama ba. Okay. The number 1. 2 to the 16. So the block address is 010111. What's the block address? Bakit mali, no? 24148. Let me just check this. 24128. Baka mali yung ating, tama ba yung ating pagka-convert? 010111. Mali yung ating pagka-convert. 24,128 eh. Baka mali yung aking pag-convert doon sa original solution. Let me look at the, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Baka mali yung pag-convert ko nito, no? Okay, i-ano ko na lang muna, no? I-hide ko muna ito because I did not solve that by, I may have solved that by hand. Baka mali yung aking solution, computation, no? But this one I think is correct because this is done in Excel. Let me upload this. May oras pa tayo, no? Direct map cache sample exercise. Ko. So it's there, no? Iba rin yung iba, this is a different example. May ang dami na nating ano. Tabi ko lang sila, no? Yung katabi niya yung ano, solution to sample problem. Okay. Do you follow? Ngayon, meron pa tayong isa. Okay. Set associative cache. At next meeting ito, no? Sorry, hindi pa ito ngayon, no? Yung pang isa. Ito. Problem 4.8. Ito. Consider a machine addressable memory with a cache of 256 bytes, 256 bytes, and a block size of 8 bytes. Okay. So, how many blocks are there? 256 divided by 8. Assume that a direct map cache consisting of 32 lines So which means that there are 32 lines. Bakit nag 32 lines? Two five six divided by 8. Can we compute that?
Sir.
Tama ba? Tama ba 32?
Yes, sir.
Walang problema. Ang problema pag kulang, di ba? Pag mali o kulang. So, a direct map class has 32 lines. Okay? So, 256 times 8 daw. Sandali lang. 256. Hindi talaga ako, diskumpiyado lang ko gamay, no? Bakit kasi niya inulit yung sinabi niya? It's not necessary. 2048 man lagi. There should be 2048 lines. Okay? Ano, mali ako na. So it should be divided by equals this divided by 32, no? So we have 32 blocks. Consider a machine with a byte addressable memory of 256 bytes. Yung buong cache is 256 bytes. And a block size of ano. So there are 32 blocks in the ano. Okay, 32 blocks. So we can copy our ano 32 blocks. So medyo mahaba, no? Let me copy our previous Excel. Dagdagan natin ito ngayon. No? Kung 32, 1, 2, 4, 8, 16, 32. You'll have 6 bits. Okay? Kaya pa natin ito. Hindi kaya, kayo nang bahala. Pag hindi kaya. Ganun talaga yun. Pag hindi kaya, charge to you. Ito na lang. One, two, three. Problema, maubusan tayo ng kulay, no? Ito eh. Ikaw, kulang. Hanggang 31. Huwag na lang tayo magkulay-kulay. Kulang pa isa. Ito yung ating cache, no? Was bin detect. No, that to bin. Ito kaya na to, no? Tama. 6. Is that correct? 6. Okay. 6. Oy. 5 lang. 5 lang, no? You only need 5 bits. Save ko ito as, ano to? Problem 8, page 148. Is that correct? Problem 4.8, page 148. No? Have you solved this? Have you solved this? Wala yung nakasolve? Wala lang siguro gisolve. But this is easy, no? For 8, page 1, for 8, 9, 9. Okay. Okay, sorry, Control C. Ano? Sige lang, disregard na lang muna. It doesn't matter whether it's valid or not. Okay. 256 bytes and a block size of 8 bytes. So hanggang 7. At i-continue na lang natin ito. This is 4, 5, 5, 6, 7. Okay. So isang linya. Okay. One line of cache is 8 bytes. Okay, that's what we have. How is a 16-bit memory address divided into tag? Okay. So 16-bit memory address 2 to the 16 is ano, di ba? 2 to the 16 65536 2 to the 16. Saan itong raise? Okay. So 16-bit address. Do you follow? Do you follow? Okay. For 8 bytes, what is the offset? Anong offset natin dito? Offset is 3 bits. Do you follow? Any questions? Bakit 3 bits? Do you follow? Because we have 8 bytes.
Yes, sir.
So, di ba? 3 bits yun, di ba? And then for cache, cache address, how many bits?
5 bits.
5 bits. Why do we know that it's 5 bits? Because there are 32. So 5 plus 8 is 16. How much is the tag? How much is the tag? 5 plus 8 is 5 plus 3 is 8, so we'll have 8 bits. Do you follow? Di ba? Tama ba? Kasi 16, sa 16, ginamit natin yung 8. So may 8 pa na iwan. That's what the thing that's left is the tag. Wala nang iba, tag yun. Di ba? In what line would its address be stored? This is number 1. This is number 1, no? What is the cache address? Ibig sabihin, what is the cache address? Oh. Ano na yun? Hirap, no? So, kaya ba ito sa ano? Bin to deck 001 001 001 1011. Okay? Kaya ito equals bin to deck. Kaya, hindi kaya. But anyway, we know it already, right? Do you follow? Because we take the 3 bits 011, right? And the next address is 5 bits. So what's the address? 00011. 1, 2, 3, 4. Okay? Because there are 5 bits. So itong 5 bits ang may iwan. So this will be the tag. Tag na itong nandito. Ito, kaya ito ng bin to deck. Isa-isa na lang natin. Equals bin to deck. Okay. Which line would this come? Would go? Saan siya papunta? At cache number 3. Do you follow? Then what will we have? Kopiyahin natin ito. Oh, bakit ganon? Ayaw niya. Okay. Do you follow? Five bits, di ba? Okay. And then what will you have? We have this here. So we'll take the first 3. Okay. 0, 1, 1. So what will we have? 0, 1, 1. 0, 1, 1. 0, 1. Do you follow? Kinuha natin yung 5 bits dyan, okay? We'll copy this. Put it here. Which block is it going? 5. Okay? Bold na lang natin ito. Yung mga answers. Okay? So, which block is this going? Kunin natin 101. So, what will that be? 101. 0011. Okay, pareho sila nung first. 00011, right? We'll just copy this. Okay, and we'll bold this also.
Ay, sir, yung second, sir, hindi ba 00110, sir?
Yeah. 00110. Oh, tama. Ano, di, kulang, kunin natin yung tatlo, di ba? So, 1, 2,
So, 00110 siya, sir.
00110. Oh, tama. 0011. Mabaligtad yung aking 0 at saka 1. 00 110.
110.
Di, kulang pa. 5 man.
Dalawang zero sa start,
Dalawang
sir.
0, sir.
Dalawang zero sa start.
0011, sir.
Okay. Okay, so 6. 6 siya papunta, no? Thank you, no? Doon siya papunta sa cache 6. Okay? So ito, what is this? Can you show me this again? At yan, sir, medyo nahirapan ako tumawag. What's the first? What's the 5 bits?
10101, sir.
10101. Okay? We'll just copy this. Oh, that goes to block 21. Is that okay? Yes, because we have 32 blocks in the cache. Do you follow? No? Suppose that you have an address. What is the address of other bytes stored along with it? Ito ngayon, kasi kukunin natin yung edge of the same block. Do you follow? Saan siya nagsimula? What's the beginning address and the ending address? Do you follow? Paano natin ito makakuha? Okay. This is number 2. Actually, we compute the beginning. Oh, ayan, beginning. Ending. Containing the address. Okay. Actually, kukunin natin yung beginning address nito. Wala na siya ilabot. You follow? Okay. Okay. What's the memory block? Memory block. Kuha na to itong last 3, di ba? Dito na tayo mangopya. Kunin natin yung last 3. Oy. Okay. Sorry. Tama ba ako? Yun yung memory block. What's the beginning address? Zero, zero, zero. Diba? Tatlo lang naman eh. Diba? What's the ending address? Tatlo lang ba sila? Yes. That's 1. Okay. Offset, offset, no, offset. Okay. So what's the beginning address? Gawin na nato ni. Diba? And then dagdagan natin ng 3 0. 1, 2, 3. Uyay ka. Mali. Lagyan natin ng quotes. Okay. What's the ending address? Instead of the 0, 0, 0, we'll have 1, 1. Tama ba? Tatlong 1? Yes. Can we compute this? Kamu na bahala kung di mag-compute, no? Diligid siya mag-compute. Into deck, no? You determine the binary equivalent. Do you follow? Basta mo na yung sinugdanan. These are all the bytes comprising the same block. So kung baga, on the same, they belong on the same block on the street. Do you follow? The same street, the same block. Okay. How many total bytes of memory can be stored in the cache? Why is the tag also stored in the cache? How many total bytes in memory? Alam na natin yung lesson ng ano, di ba? What's the total bytes? 32 times 8. In cache. You have 32 times 8 equals 256 bytes. It's already given, no? Almost stupid, no? Why is the tag? Can you explain me at the answer? Why is the tag included in the cache? Diba?
Sir,
Diba ito yung tag, ito yung cache natin. Nilalagay natin yung tag sa cache. Why is it? Huh?
I forgot po, sir.
Because without the tag in the cache, remember there will be several blocks in memory which will be sharing the same tag. Do you follow? At the same cache but different tags. Diba? Like in this case, how many blocks do we have? 31 blocks, but how many memory blocks do we have? How many memory blocks actually? Tingnan natin. We have 64K, 65536, right? How many blocks in memory? 65536 and 8. Okay. There are 8K bytes. There are 819 to 8K blocks, right? 8,000 blocks. We'll share 8,000 blocks will share 32 blocks in cash. You follow? So 8K divided by 32. 256. Okay. So one block in cash. One block in cash will be shared by 256 blocks in memory. So 256. Sorry. What's log 2 of 256? 56 equals, sorry, equals log. So 8 bits, kaya 8 bits. No? Tag. Tag. Do you follow? 8 bits of tag. 8 bits ba? O di ba 6 bits lang? Tingnan natin. How many bytes are this? Okay. 8 bits of tag, oh. Nakakompute natin 8 bits of tag, right? Do you follow? Why 8 bits? Because there are 256 of them. For example, ang mag-share dito sa block 0, ang mag-share dito will be, mali ito, no? Dapat mag-0 tayo magsimula, no? Ang mag-share dito sa block 0 will be memory block 0 and memory block 32. Do you follow? Ang mag-share dito, this will be shared by 0, 32, 60, 0, 32, 64, 128 ang mag-share dito. Dito ang mag-share is si 1, 30, 33, 65. So this will be shared by this. How many will share in this in this space? 256 blocks in memory will share this. Si 0, si 32, si 64, si 128. Okay? What's next to 128? Si 256. Okay? Dito sa 1, who will share this? Si 1, si 33, si 35, si 65, si 129. Okay? Sila mag-share. So therefore, we need to put the tag here to find out which block in memory is placed here, is occupying the actual tag. So what's the use of the tag? The tag determines if the correct block in memory is in the cache. You follow? Kasi there might be a correct, a wrong block. Di ba? Did you notice our trace before? Diba, i-trace natin. Pag mali yung tag, we miss and replace. Where is that? Sa trace. Ito, no? Nasa Dagler ito, no? This one. When we trace the direct map cache. Una. Okay. Anong address? The first address is this. Ito, no? The first address is 2. So 000, the block address is 0. So inoccupy natin. But take note that pagdating dito, we have the same block address 00, right? But the tag is 10. So therefore, we cannot place it here. Kasi it's being occupied by 00. So therefore, this is the wrong tag. So therefore, we have to unseat this, no? Papalisin natin siya, which means we are going to save this memory before we are going to put this address here. Although they have the same cache, but they have different tag. Therefore, we have to miss and replace. Diba? Papalisin natin yung nakaupo, papalitan natin ng bago. Because they have a different tag. Do you follow? At the end, sir? Diba?
Yes, sir.
If you recall the trace.
Yes po, sir.
Okay, good. No? So, gano'n ang ano, no? Kasi papalisin nga natin yung nandun, yung nakaupo doon. Kasi how do we know na yun pa rin siya? Because of the tag that he's wearing. Okay? Do you follow? So, I'll upload this, no? Did you submit your already? With this? So, you study this, no? Because our exam will be like this. Okay, so I'll upload this anyway, no? I-upload ko na, no? Oh, tama na pala. Wala na tayong oras, no? I'm sorry for that. 1 minute na lang. Ako na bahala mag-upload, okay? Everyone, see you next meeting. Remember, no? I think first exam will be on the first week of March. Okay.
Yes, sir.
We may need 2 more meetings and then, yeah. So we can relax early. Okay. So I'll upload the recording, no? And bye, everyone. Happy Valentine's Day.
Bye, sir.
Bye, sir.
Bye, sir.
Okay,
Sir,
bye.
thank you, sir.
Bye, sir.
Bye.
Happy Valentine's Day, sir.
Bye.